Let's continue looking at problems from the Algebra 2 review, semester test review. Number 16, we have a population of 1,500 insects grows exponentially by a factor of 3. A factor of 3 each week. It means multiply by 3 each week. Select all equations that represent or approximate the population P as a function of time in days. T, since the population was 1,500. Okay, so the initial population is 1,500. That will be this part here. The factor is 3, but we're in days. It grows 3 every week. So for T in weeks, the function would be 1,500 times 3 to the T, but we're not doing T in weeks, we're doing T in days. So for T in days, there are 7 weeks in each day, so we would do 1,500 times 3 to the T over 7, because there are 7 days. So this one definitely works. And now, because of our rules of exponents, or laws of exponents, we can write this as 1,500 times 3 to the 1/7 raised to the T, because if we multiply T times 1/7, we get T over 7. And that one is this one. So those two are the correct answers on number 16. Well, number 17 says, which expression would you use to find the value of T in the equation 2 to the T equals 6? We've been doing this in class the last few days. We're going to convert this to logarithmic form, and we're going to get log base 2 of 6 equals T. That's what we're looking for here, is this expression right here. This one says, between which two whole numbers is the value of log base 2 of 6? Well, sorry. We know that log base 2 of 6 is less than log base 2 of 8, and log base 2 of 6 is greater than log base 2 of 4. Log base 2 of 4 is the power of 2 that gives you 4, that's 2. And log base 2 of 6 is greater than that. And log base 2 of 8 is 3 because it's the power of 2 that gives you 8. So we know that log base 2 of 6 is between the whole numbers 2 and 3. And this is how we know. And let's look at 18. Here's the equation. Here's the graph. Represents the bacteria. Represents a bacteria population as a function of time in hours. Here's the graph of the function P. Use the graph to estimate when the population will reach 100,000. This is the population in thousands. Here on the graph, we can look at it. And we could say that that's a little less than 4.5, so I'm going to say at about 4.3 hours would be a good estimate for that. It says find the exact time when the population will reach 100,000. To do that, we're going to set P of H equal to 100,000. We're going to divide both sides by 5,000. 100,000 divided by 5,000 is going to be 20. That equals 2 to the H. We're going to convert this exponential equation to logarithmic form. Get log base 2 of 20 equals H. This is the exact time. We're going to type that in our calculator. Math, log base, and get log base 2 of 20. And that looks like 4.322 hours. So we had a pretty good estimate from the graph. 19 is going to be our last one because we have not done the transformations, and I'm going to drop those from your semester test. I'll teach you those in college algebra though. So we're going to solve these equations real quick on this last video. And we're going to take this equation, we're going to divide both sides by 4, so I get 10 to the x equals 100,000. Convert that to logarithmic form, we get log, remember base 10 we don't write, of 100,000 equals x. And we can type that straight in our calculator using the log button of 100,000, and that's just 5. So for A, that's 5. I'm going to go over here and do B. 10 to the n plus 1 equals 1. We convert that to logarithmic form and get log base 10, we don't write base 10, of 1 equals n plus 1. The power of 10 that gives you 1 is 0. We can do log 1 to verify that. So that's just 0 equals n plus 1. So we subtract 1 from both sides and get n equals negative 1. That's B. For C, we can take 10 to the 3n equals 1 million. And we convert that to logarithmic form. We get log of 1 million equals 3n. And we divide both sides by 3. And we get log 1 million, all divided by 3 equals n. Type that in our calculator. Log 1 million. Close your parentheses there. Make sure you do that because it will be wrong if you don't. Divide by 3. And we get equals 2. And that's part C. I'm going to come over here and do D. Get 10 to the p equals 725. We go straight to logarithmic form there. Log 725, that's log base 10, remember, equals p. We can type that in our calculator. So that's going to be 2.86. And then for E, 6 times 10 to the t equals 360. Divide both sides by 6. 10 to the t equals 60. We're going to rewrite that in logarithmic form. Log 60 equals t. Remember, log base 10. So we're going to type that log 60 in our calculator and get 1.778. And that's how we do number 19. And that's the end of your review for the semester test.